morning, pilot teachers and students. Good morning, class. All right, thank you very much. You can sit down. All right, our last lesson was basically on action and reaction forces, and you were given some examples of these action and reaction forces, and from this you know the effect of action and also the reaction as well. Now in this lesson our topic discussion will be basically on density. Now can someone give me the definition of density? Mary, you give us your explanation of density. Okay, quickly pass this.
Density is the amount of milliliters per cubic centimeters.
Okay, density, from Mary's explanation, density is the amount of mass per cubic centimeter. Has anybody got a different explanation of that? Okay, very good. So from definition we can see that density is the measure of amount of particle in a given space, or it can be simply the mass per unit volume. So basically we'll be going through and then looking at density. Now pilot students, after we've gone through these notes, I will be asking you to copy the notes, and then after that I'll be giving you some problems or some questions at the end of the notes. And when you look at that, again, in the next lesson, I will be asking you to actually go through and then measure density of various substances. Right, quickly go through and then take these notes down. All right, next. Okay, do not copy this one. This is just for explanation. You will find that the wood is less dense than the metal. And also you'll find that the metal is something like this. You find that it is more dense than the wood. Okay, for the liquid as well, if you find later on when you come to liquids, you will know the pressure. When you measure pressure liquids, you know about the density of these liquids. So it can be more similar to liquids. Okay, there are some liquids which are more denser than the others. All right, quickly have the formula. Now before you copy that information, I'll quickly go through to measure the density of. You'll find that the density is given as mass over the volume. So mass is measured in kilograms, and the volume in meter cube or cubic meters. And density is measured in kilogram per meter cube, or it can be in other units of mass, which is and other units of length. For example, it can be in grams per cubic centimeters, or it can be in milligrams per cubic centimeters, or milligrams per cubic millimeters, or something like that. Okay, so these are all the units of, but if you have to look at it in dimensional unit, it is ml minus 3, so that is for mass length cube. Okay, now sometimes you'll find that it is given by this information here, right? You will find a symbol that is rho for Greek letter, something like P equals to m over v, so you have mass over the volume. So this, if you find something like this, it is simply density, as well as this one. All right, quickly go through help that information. Okay, now to the next piece of information. Right, basically when you're trying to measure the density of a certain object, for example, if they are irregular, right, you've measured the volume of some of these already when you studied volume. So simply put that into a cylinder and you will get the difference in the reading. That is simply the final reading minus the initial, gives you the volume. So volume is simply when you have to change that milliliters to centimeters and then to meters. Right, students, please have this information quickly. I'll give you the next information or slide on. Okay. Okay, when you have this one, the relative density. Relative density is simply when you have to compare the density of that substance with water, and that is given by this formula as relative density, or density equals to density of the substance over the density of the water. So that is when you are simply comparing the density of a certain substance with the density of the water. Okay, you use this formula. So quickly go through, have this formula done, and then I'll give you your activity. Okay, pilot students, you can also go through and then take these notes down. All right. Pilot students, you should have finished by now. Right, we will now go through the density of some of the substance. This is just to give you some idea, right, for solids, liquid, and the gases. Right, for solids, you have the gold, that is for solid. Right, density in grams per cubic meters would be 19,000 kilogram per cubic meters. And if it was in grams per centimeter cube, you should have 19. Okay, similar to the liquid, which we have an example, which is water, and also the air. Right, so those are some examples. You can quickly have that example done into your book. 90,000 kilograms, then you have 19. Okay, that is correct. You know how that is converted? You change. Okay, I'll explain to you later. All right, some of you, let's go through this one again. Why do you have this small number? Some of you are arguing that probably 19 would be somewhere here. Okay, that is not correct. If you have to, this one is supposed to be as it is. Okay, you have 90,000 kilogram per cubic meters, and that one should be grams per centimeters. Now, if we look at how we can convert this one, right here is it. It is. You're trying to change this one to kilograms, so it'll be, you'll be dividing that. You remember when we were going through conversion of units, okay? And this, so that will be 19 divided by 1,000 if you're trying to change that to a much more larger unit. And then you have this one per cubic, or let's say centimeters square. You are trying to change that to meters, so it'll be 100 times 100 times 100, because 100 centimeters equals to 1 meter. So you have to make that change the reciprocal of this one, that is 19 over 1,000. Then you have this one, which gives you almost about 1 million. So you cancel this 19 times this 1,000 will be 90,000 kilogram per cubic meters. So that information is quite correct. You just go through and then finish. All right, now to the activity. You finish this. Okay. Pilot teachers, you can also ask the pilot students to quickly go through and then copy this activity down. There are 3 activities in this lesson. I will give you time to copy and then probably time to work out those questions. Okay, copy the next activity. Now to the last activity question. Hey, you watch where you are leaving that thing there. All right, just place it on that nicely and then leave it stay. Yeah. All right, go through and then quickly work out those answers. I'll give you a few minutes. What's the time? Okay, let's see. We will. Question number 1 and 2. Okay. Malcolm, you get ready for question number 1. Number 2 will be. Who do we have? Okay. Kimberly, you to question number 2. Question 3 will be. Question 3A is Michael, and 4B, Joseph. Okay, question 4B will be Joseph. So number 1 again, Malcolm. Question 1, question 2, question 3, and question 4. There's no? Yeah, B. All right. Pilot teachers, you can now ask their pilot students to give you their answers to those activity questions, while the model students will show you also how they have taken the answers. Okay, Malcolm, yours is first question. You come up to the, okay, so you're working out and then you explain. Go back. Okay, what's this one too? Just leave it there, the microphone, yeah. Okay, clean that using that piece of, there, that's it.
Because the mass of the lead was 44,000 kg, I divided it with the volume, which is 4 meters cubed, and I got 11,000 kg. kg per meters cube.
Okay, that is the answer to question number 1. Let's go to question number 2. Come here. What is your answer to that? 1.3 times 50.
1.3 is 1.3 kg per meter cube is the density, which is equal to mass over 50 meters cube, which I got from timesing 4 meters by 5 times 2.5 meters, and all you got, you just have to bring 50 times 50 on both sides, and you get the mass of 65 kg is the mass.
Right, that is the answer to question number 2. Right, simply using that formula, density equals to mass over the volume, and then this time you are asked to find the mass. You have the volume and also the density given, so it'll be density times this mass, or rather the volume, because when you have to multiply, right, 5 times 4 times 2.5, it will give you, all right, 50. So 1.3 kilogram per cubic meters times 50 will give you the mass as 65 kilogram. Okay, that is correct. So this. Okay, we will go to the last question, and there are 2 parts to that question. Question 3, we have A and B. So A will be Michael.
The volume, the mass of the iron is 8,000 kilograms, and the volume of the iron is 1 cubic meter. So using the formula, density is equal to mass over volume. We arrive at the answer of 8,000 kilograms per cubic meter.
Okay, good. So the answer given there is 800 kilogram per cubic meter. That is correct. Okay, we'll have
I got my answer by multiplying 8,000 kilograms by 1,000 because we are changing from a larger unit to a smaller unit. And also the hundreds I got from M3, which is 100 centimeters equals to equals to 1 meter. Because it is M3, got three 100s altogether. I multiplied this across, I get 8 million. I multiply this across, I get 1 million. I divide that into that, I get 8, which is equals to 8 grams per cubic centimeter.
Okay, very good. The answer is right 8 grams per cubic centimeter. Right, let's explain. That is right. Right, that is simply 8,000. If you're trying to change that, you will be multiplying by 1,000 into. Okay, because you're moving from larger unit to smaller unit, you have to multiply, and then you have to determine how many places you're moving. So it is 8,000 times 100. Okay, divided by, because you were changing that from large unit to smaller unit, so it, 100 times 100 times another 100 over 1. Okay, this one will be over 1. So when you take inverse of this, it will be 8 million over 1 times 1 over 1 million. Right, that is gives you the answer is 8 grams over per cm cube. Okay, so that is how you can arrive with that. Right, so those are the answers to our activity questions. Anyway, you have just seen how we can go through in calculating the density of the object. Density is simply the measure of amount of matter in a given space, or it is simply the mass per unit volume. But if we are trying to measure density, or if we are trying to compare the density of a certain substance with, let's say, that of water, then we call it as relative density. And that is the density of the substance over the density of the water. And that is how we can arrive with density. So it is simply designated or denoted by that sign, which is rho. Okay, that is rho. Density, which is equal to mass over the volume V. Okay. Right, that brings us to the end of the lesson. And in our next lesson, we'll be also looking at density, but this time we'll be doing a little practical on density. Okay, how you can measure density of certain substance. Things that you can prepare, pilot teachers, you can also prepare these following things. You can have stones, measuring cylinders, and also balances. Okay, that should get the volume, and for measuring cylinder, we should, by using that, we can be able to measure. So that is in our next lesson. Right, our keyword for today would be simply density. Good afternoon, pilot teachers and students. Good afternoon, class. Okay, thank you. You may sit down.